The other rule that's useful, of course, is the cosine rule, which really is, when you think about it, Pythagoras' theorem on steroids. So it allows us to use Pythagoras' theorem, but not just for right-angled triangles. Let's derive it. So once again, I'll drop in a perpendicular height here, which I'll label h. But you'll notice I've also labelled down the bottom there x. And in that right-hand side, I can say, well, h squared must equal b squared minus x squared. Now, c squared, if I look at the left-hand side, if I've called that little bit x, then the base of the left-hand side right-angled triangle must be a minus x. So we know c squared must equal h squared plus a minus x squared. Well, if I substitute in the h squared, that'll get rid of the h, and we'll come up with a formula that just has a, b, c's, well, and x, but let's see what happens. So I now have c squared equals b squared minus x squared plus a squared minus 2ax. But the minus x squared and the plus x squared, that'll cancel. I now just need an expression for x in terms of the information we know. And what I do know is x over b is the cosine of the angle C. So I can substitute that in, x equals b cos C, and we get Pythagoras' theorem on steroids. So there's your c squared equals a squared plus b squared, but we got the little extra bit there which accounts for it being not right-angled. Because of course if it was a right-angled triangle, you'd have cos of 90, and cos of 90 is 0. And so you get Pythagoras' theorem. A squared plus b squared is c squared. So in any triangle, depends which side you want to find, but basically you want the opposite angle to the side you're trying to find. So when it's a squared, it's cosine a, and when it's b squared, it's cosine b, and when it's c squared, it's cosine c. So you want the opposite side to the to the angle. All right, let's do an example of one then. So we're going to find t. So for this one, t squared will equal f squared plus m squared minus 2fm cos t. Substitute in. Now, I think most people probably do it all in one hit when it's just numbers, but the most common mistake is forgetting to square root it all. So remember, that's a formula for t squared. So once we've plugged all that information in, going to have to find the square root of that to get t. So this particular one, to the nearest whole number, is 8. Now if we're going to find an angle, well, we're going to need all three sides of the triangle to do that. Some people just use the same formula and rearrange it to make cos f, in this case, the subject. Others just remember the formula with cos f as the subject. I suppose it doesn't really matter how you get there. So for this one, we want cos f equals, and it'll be a squared plus s squared minus f squared over 2as. If you are remembering it in that form, I guess the thing to remember is it's minus the side opposite the angle that you're trying to find. So subbing that one in, and unlike the sine rule, we don't have the problem with obtuse angles, because the cosine button on our calculator will bring out obtuse angles. And in this case, actually does turn out to be obtuse, 140 degrees 33. Something like this. So we'll get a question like this and we go, okay, I'll use the sine rule. Oh, hang on a sec, I've only got one angle. Okay, I'll use the cosine rule. Oh, hang on a sec, I haven't got the angle opposite the side that I want to find. You can still use the cosine rule. Okay? If I set it up, I still make the subject the side opposite the angle I know. So in this case, A. So I'm going to say a squared is b squared plus c squared minus 2bc cos a, and substitute in. And, well, I just want to make b the subject. I'm going to end up with a quadratic equation, of course. So b squared minus 14b cos 25 plus 40 equals 0. I'll end up with two possibilities for b, and depending on whether I've got enough information to narrow it down to one, I might be able to. Otherwise, best I can do is say, well, it's going to be one of these two things. So this particular one, we've got 14 cos 25 plus or minus square root of 196 cos squared 25 minus 160 all over 2, which gives us two possibilities. And in this case, there really isn't enough information to be able to narrow it down. One thing there is something I can conclude from that, isn't it? Looking at the two possible answers, what I can conclude is C is the largest angle. So the cosine rule. So 4i, if I remember correctly, is on the cosine rule. 4j is just a mixture of trig questions.